Thanks for having me today. My name's Chris Love. I'm with a company by the name of CNM Consulting, but you notice that Google's pasted all over my slide deck, and I don't have the clicker. The big one. The big green button. All right. So as I was mentioning, my name's Chris. I'm with a company by the name of CNM Consulting. We do work with Google. We've been on a project called Helmsman, which is focusing on the hosted version of Kubernetes, which is called GKE. And today we're going to talk about using Bazel with containers, with Go, and deploying it out to Kubernetes. And I have a demo, so let's see how this goes. So we're going to talk about how using Bazel to maintain, build, and test your code, as well as deploying out to containers and Kubernetes, and really why Kubernetes, in my mind at least, is becoming the standard for container automation. On top of that, Bazel, we're at Bazel conference, we want to look at both building containers as well as deploying all the way out. Containers. So a quick temperature check. Who's using containers in production here? Good. Google's been using them for about 12 years now. And everything inside of Google, or a lot of stuff inside of Google's running in containers. Google Maps, just about anything that you hit, it's running in containers. And really, containers are about two things. They're about the image, so you've got an image that you can maintain. You don't have to maintain the whole thing, right? And what I mean by the whole thing is you have a node, or a compute unit. You've got security patches to put in that compute unit. The security patches theoretically are going to be a lot more smaller on a container. And then you've got your runtime, which is your executable. And that is an isolated process, of course, with C groups and everything else within the Linux kernel. We've got a bunch of buzzwords out there. We've got lightweight. Like I said, it's not a node. It's just a process or a couple processes that you're running within the container. You've got portability. I can run the same container that I'm building today on my Mac that I can run up on a Linux node, and theoretically, maybe sometime we can run on Windows. They're also fast. A virtual machine in the cloud takes a while to deploy, and then it takes a little bit longer to boot. If you're on bare metal, you run into the same issue. Container is, like I said, it's a process or a couple processes that you're running within your image, and it's a lot faster to boot. So if you're talking about scaling out from 40 pods on Kubernetes to 900, you're waiting on the scheduler. It makes our life really different. You're looking at deployments are now handled differently. You're looking at management, monitoring. You're looking at isolation process, very complicated. You're looking at updating, discovery, scaling, sets, HA. Our playing field's been totally changed because of containers. In a good way, I'd say. But we now have to deal with that stuff. Storage, big challenge with containers. Load balancing, discovery, running multiple applications on the same node, because you're looking at different ports now. Security, when is security not a challenge? Failover, and of course QoS. Let's prevent race conditions inside of our containers. That takes down another container that's on the same node. So now we've got this great topic. It's called Kubernetes. And really, what's all the buzz about? And let me tell you a quick story. I didn't understand containers. I was a puppet guy. I'm sorry. At least I can unit test it. So containers came along, and like, really? I need this now? Why? OK, well, let me try it out. Did a demo a while back, thankfully to Google. And I was able to deploy out 1,000 nodes of Cassandra running on a cluster of Kubernetes. And I had a Java application that was the front end for it. So fired up. Well, and then I put an ingress in front of it. And if anybody here is familiar with an ingress, there's a health check on it. And all of a sudden, my deployment of 30 pods, which are 30 containers, got 1,000 ingress health checks. I'm sure people can go, OK, what happened to my heap? Yeah, pods were crashing. All hell was breaking out. So I hit a button, and I went from 30 pods to 900. And suddenly, as the volume of pods came up, it was actually able to handle my ingress check. That's when I got the understanding, okay, this is why I need containers. This is why I need an orchestration system that allows me to manage those containers in a reasonable way, where I can do this, and now I scale. Google introduced containers, or Kubernetes, as an open source project. As I said, it manages containers within your cluster. Brian Grant really hates it when we say that it orchestrates containers, but in a way, that's what it's for. It was inspired by the internal tools that Google has, including Borg. Supports multiple clouds, including bare metal. So we can run it on Google, you can run it on AWS, you can run it on DigitalOcean, you can run it on Alibaba, you can run it on bare metal. Theoretically, those deployments you can use a lot of the same YAML to deploy from one source to another. Bare metal gets kind of interesting, and there's other differences within, for instance, storage or load balancing. But still, you're able to reuse a lot of your deployment technology across different platforms. For instance, GitHub runs primarily on bare metal. And they have a whole infrastructure with Kubernetes for bare metal. But their development all occurs on AWS. So the developers spin up their own AWS cluster, or a development team has a Kubernetes AWS cluster, but when they're ready to go to production, it moves back to bare metal. And really, you want to think of Kubernetes as your operating system for your compute fleet. It's a lot of different nice words. But in essence, you're going to have multiple nodes. You're going to have a control plane and an API layer. If you have 300 nodes, and I'm not sure, we talked about carrying pagers, but having to worry about 300 nodes or a couple thousand nodes while you're on call stinks. Now you're able to do such nice things as cordoning, draining, basically say, okay, I don't want this node, replace. At times, if you're talking about failover, you can, if your applications are developed properly, you can lose a certain amount of percentage of your nodes, and you don't even get paged at night. But we're also talking about self-healing, so if I kill a node, pods will move over. If a node fails, you know, that never happens, pods will move over and containers will move over and redeploy for you. Oh, Bazel. So I'll put in a caveat here. The gentleman from Etsy that did the presentation yesterday did a really good job on the Bazel Kubernetes rules. My slides do not compare. So just go rewatch that, and you can catch up on exactly what good Bazel rules look like. But I do have a demo. So, but we'll see how that fares. So we're talking about Go today. You can talk about Python, you can talk about Java, you can talk about any other supported language. But within the build rules, you're able to run, you know, this is basic Bazel 101, right? You're able to run building, you're able to run unit tests, you're able to do dependency management with Go, and you're able to run Gazelle. We noticed we had a demo yesterday about AutoGazelle, where you're able to generate not only the build files, but when you spike a project, you're able to use Gazelle to generate the initial build files for Go. We've got Docker. It's basically, it's a set of rules that allow you for pulling, for pushing, for building, and doing all kinds of things within them. You're actually able to chain rules together, and you're able to build your own base images. Or if you, in our example today, we're going to be using the Go base image, and you're able to make a very thin, small container that just has your application in it, and then you're able to push it up to your registry so that you've staged it. Within the Kubernetes rules, it handles authentication, which is super important and challenging within most build systems. Publishing the containers, so it will push up to the registry, and does some fun stuff with managing container digests. Instead of typically using, and we've got some work to do with this because I know there's folks that want to use tagged versions. But within a container repository, you can also typically have two different developers, and because they're theoretically working on the same container version, they can clash with each other. You can also do a sublevel with Docker v2, so that not only do I have my registry, but now I have the developer name and the container version all on the URL of your registry. We've got some capability with manifest templating with tools like KSonnet. We're able to not only write your manifests in YAML, or you're able to choose a tool such as KSonnet to develop the manifest with it. Also, full CRUD really for your application. We're able to deploy the manifest, you're able to delete, you're able to apply, et cetera, et cetera. So from a build standpoint, you have a cluster, you have your code, you're able to build your code, you're able to build your container, you're able to deploy that container out for yourself. Want to give a couple people thanks for this project. Eric Cole as well as Shravani, both on the Helmsman team, helped me out immensely with this. So let's talk about the demo a bit. It's actually a little bit complicated because I call this our kitchen sink demo, because basically we threw the kitchen sink at it. We've got about 17 different demos running around right now. Actually, it's more like 20. And this one incorporates 2 different clusters. What we're looking at is we have a on-prem cluster, which is actually run in the cloud, that is networked in via VPN. The on-prem cluster is running Elasticsearch. We're not going to mess with that at all today, but that's our data store. And that would be, say, you've got data issues where you don't want to take all of your data, move it off cloud, and then onto cloud. And you've got Elasticsearch, which Elasticsearch is really good for doing HTTP communication, say from on-prem to cloud. Then we've got a couple different Pyrus pods, and I noticed that there's a typo in here because I actually have 2 pods, or 2 deployments, not just one. We've got a Golang pod that's actually just a proxy into Elasticsearch, and then we have a UI pod, which also creates nice, pretty HTML. All right, if we can get back over to here. We get switched over to my laptop. Be great. So let's take a real quick walkthrough through our build file. As I mentioned, see if I can get all the way to the top. There we go. So as mentioned, and this demo is out on GitHub. It's a little rough right now. I'll be cleaning it up over the next few days, but it really goes from soup to nuts. So we've got Terraform that will create your clusters. Basically what you need is Terraform, G-Cloud, and Google Count. It'll spin up 2 different clusters for you. It'll network in the VPN. It'll create the VPC correctly for you. It'll create subnets. It'll install everything for you, including Elasticsearch. You need kube control as well, of course, installed locally. So looking at the rules, you've got, we set up our Go rules first, and then we're looking at the Kubernetes rules. Actually, let's talk about the container rules as well. Set up the Docker rules, load everything here, and then we're loading our container rules. And then you'll notice that we've got a bunch of different Kubernetes rules. We've got rules for services, we've got rules for deployment, and then we've got rules for objects. It's kind of nice because within Kubernetes, one of the challenging things is YAML hell. And what I mean by that is you get a lot of different YAML, a lot of different YAML files. Within Bazel, you're able to chain together, or I'm not sure if chain is the right word, but you're able to group together, okay, this application takes this deployment, this service, et cetera, et cetera. We're building the Go binary, which is a Pyrus UI. We're going to mess with logging within the Go Pyrus UI to see if it works here. I'm doing dependency management, and VGO is kind of taking over-ish. We have dep, we have glide, we have VGO. We've got a lot of different dependency management going on in the Go ecosystem, and we'll see exactly where this leads. But for this demo, and since I'm at the Bazel conference, I chose to do dependency management right in Bazel. Then we've got the image. We're embedding the library that we built, as well as we talk about architecture here. Then we've got the container image. So we're setting up the work directory. And theoretically, or not theoretically, but my project currently contains a Docker file. Because when we started this project, it didn't have Bazel built into it. So we're actually going to remove the Docker file. We're going to remove the make file. We're going to remove a couple other building components out of it and just use Bazel for deployment for this demo. Now here's the interesting thing, is you now have a deployment manifest within your build structure. And talking about a lot of things in terms of keeping deterministic and heuristic and all those wonderful words within your build infrastructure, but including YAML that is the source of truth for deployment within Kubernetes is is essential to creating good testing as well as standardized deployments. You'll also notice that we have cluster and context and repo that are set up to be passed in to this demo. So theoretically, you could deploy it to a different Docker registry, as well as you could deploy it out to different Kubernetes clusters, depending on what environment you're in. If you're in development, you're able to do the same build, as well as test, as well as dev. Or production, actually, is what I meant to say. And then you notice the Kubernetes objects. You can add multiple objects, which are basically multiple different Kubernetes manifests, which of course are the YAML objects that are used against the API to create and deploy your containers. All right. So I'm going to run a expose command here, which is kube control. And I don't have a load balancer set in front of my UI. What I just now did was I proxied that container to this local host. And let's see if this works. Excellent. So now we can see that the Shakespeare data is there. It's connecting in with Elasticsearch. We're getting multiple results for Leonato. What we have is we have all of Shakespeare loaded up in Elasticsearch, complete work. And we're running a query against the cluster, and it's coming back with that data. Take a quick peek inside the pods, and I'm actually within the Google Platform UI here. And you can see CPU usage and all that good stuff. Great. And if we go back here, we've got the workloads coming up. So we're going to play with Pyros UI here. And let's bounce out of the UI real quick and get back to where I usually live, which is I have K alias to kube control because I'm really lazy. So if you notice, I just did a call against that cluster, and we've got 2 different pods up and running. And of course, I left my cluster up and running overnight because I want to reduce the amount of risk for my demo. And I've already run this once. So we've got a pod that's up that's 2 hours old. So let's go into our source code. I'm going to cancel out of this because hopefully that pod's about to go away. Let's see if I can change the directory correctly. All right. So we're just going to add in another log statement. Bounce back up here. What I've got is a couple different commands here that I'm about to run. First one is the Bazel build command for the target of the K8s apply. And I showed you guys the rules. And at the end of the day, everything chains together, and we're going to run kube control apply on that Kubernetes object. So again, we're going to build the Go. We're going to push the container up to the registry, and then we're going to run the apply. I'm actually running both the applies for Pyros as well as Pyros UI. So theoretically, I didn't change the container for Pyros, but I did change the container for Pyros UI. So theoretically, one of the Bazels or one of the applies should not have to run. All right, build successful there. And this is all building locally on my machine. So Pyros is unchanged, and we found the target, and we applied, theoretically, Pyros UI. So if we go back to the UI here, see if we catch it while it's actually deploying, or it's going to deploy incredibly fast, which it did. Awesome. Hey, this will tell us if it worked right. Yes, excellent. So we've got a pod that's coming out now, and it's started. So let's go hit the proxy again, set that up, because we're proxying the exact pod. All right, it found the pod. hit the web page again. Excellent, came back up. But really the real thing is if we do a get logs on this. Let me not get the logs there. Let me get the logs to the right pod. Helps if I type the right command. Excellent. So there's our change. My demo actually worked today. Thank you. So we got 15 minutes left. How about some live debugging? And actually, I need help. I know, right? Crazy. So I've got actually an issue right now, and somebody can hop up to the microphone for me and help me out if somebody feels brave enough. I'm making a change to the HTML under static, and I think I need a build file. I'm not certain, but it's not updating in the container. So you'll notice that we've got enterprise best practices up on the HTML. If nobody's up for this, hey, we don't have to do this. No pressure. But you'll notice that this morning I went in and I made the change. Or did I? Well, let's do this again here. And let's see if I can spell. It'll go through and it'll run the build. And now maybe it is working. Nope, it said the Papyrus UI is unchanged. So I am listing the static as a component within my container. So it is being built properly, but anybody have any ideas? Let me get back to the build Bazel and Atom. Because I'm listing the files and the work directory within the container image. But I'd love to know why my demo wouldn't work in the manner that I had assumed it would. Any ideas? No? Eh, all right. Excellent. We tried. If I could have the slide deck back up, that'd be awesome. So as I was mentioning, worked with Google Professional Services on Project Helmsman. What that consists of is some base level best practices. Okay, I want security within my GKA cluster, great. Here's about 5 different examples of how to do different security, whether you're looking at networking or you're looking at RBAC, et cetera. We're gonna, if you're actually a Google partner, you also have access to about 10 different decks that we built. For example, security is actually 2 decks, about 50 slides each, and you're able to pull out of that content to help out your customers with that. There's a short link to the different GitHub projects that are open up, so I'll leave this slide up for a moment. If you folks want to take a look at that, they're up on GitHub. We love contributions. We open source at Next, so we haven't had the contributions that we're looking for quite as well. And if you want to contact me, I'm pretty much Chris Love CNM everywhere. GitHub, Twitter, et cetera, et cetera. So please reach out if you have any questions. As I mentioned, love to help you and love to have anybody here contribute towards the Helmsman projects. Thank you.